For us humans, our planet is massive in all dimensions. But in the grand scheme of the universe, we don't even make up the top 5 biggest planets in our solar system, much less the universe. And while planets like Jupiter dwarf Earth, scientists have discovered a planet that makes Jupiter look like the Moon. This planet is so unusually massive that it's the first of its kind ever to be discovered. And what's more, it's still growing. So, join us in today's video as we explore the largest planet in the universe. The universe is barely 13.5 billion years old, and in the grand scheme of cosmic timelines, the universe is still in its infant stages. As such, stars and planets are still forming. With the help of advanced telescopes, we can watch and study some of these stars and planetary formations. In their study of the universe, scientists have come across an unusually large planet with massive proportions that were thought to be impossible. AB or IGB. Introducing AB or IGB, a young protoplanet barely in its infant stages orbiting an equally young star in the most unusual and unpredictable process of planetary formation ever recorded. AB or IGB is a massive gas giant similar to planets like Jupiter, such that it largely consists of a gas exterior with possibly a small rocky core. It is currently only made up of vast amounts of hydrogen and helium, and while planets like Jupiter are incredibly massive, it trumps Jupiter in size many times over. To put this in perspective, Jupiter is the largest planet in our solar system, and compared to Earth, it is almost 320 times the size of Earth. If all the other planets in our solar system were put together to form a superplanet, Jupiter would still be more than 2.5 times the size of this superplanet. In other words, Jupiter is incredibly massive in its own right. AB or IGB, on the other hand, is about 9 times Jupiter's size and has a diameter almost 3 times larger than Jupiter's. What scientists have noticed that is really fascinating about AB or IGB is that it's still forming and it's very early in its birthing process. The planet is currently embedded in the protoplanetary disk of its parent star, AB or IG. The system is located in the constellation Auriga, some 530 light-years away. The lead scientist on the planet's discovery, astrophysicist Fane Curry, stated that "We think it is still very early in its birthing process. Evidence suggests that this is the earliest stage of formation ever observed for a gas giant. It is still forming." And while AB or IG is massive, it happens to be forming within the protoplanetary disk of an equally massive host star, AB or IG. Researchers were able to detect both bodies using a combination of 2 telescopes, one orbiting the Earth and one studying it from the ground. Scientists have been studying the star formation of AB or IG for over 13 years using the Hubble Space Telescope's near-infrared camera and its imaging spectrograph systems. But due to the obscure nature of such a young star-forming system, they needed to confirm the data they had picked up was actually a planet forming within the young star's vicinity. As such, they employed the Subaru telescope in Hawaii to further study the current state of the exoplanet as well as capture what would be the first ever image of a gas giant forming at such a young stage. The star is relatively young, being only 2 million years old, which compared to our Sun is a cosmic baby, in that it is over 4.5 billion years old. It appears it began its formation process after it was hit by a supernova, which is needed to kickstart the star-forming process. Over time, as the star gathers gas and dust into an expansive protoplanetary disk, the gas giant began to take shape, forming alongside its host star. But scientists realized that some things were quite unusual about AB or IGB and its host star. The star and the exoplanet were too far apart, so much so that under conventional star formation processes, it would be almost impossible for such an enormous planet to form so early in the system's lifespan. An unusual formation process. The massive exoplanet is located some 14 billion kilometers from its host star, which is roughly about 90 times the distance between Earth and the Sun. To put this in a much simpler perspective, the exoplanet is located about 3 times the distance between Pluto and the Sun, meaning its distance literally covers our entire solar system. You might be asking, why is this distance important and what does it have to do with the planet's formation? Well, everything. At such a distance from its host star, Scientists never expected a planet of such size to have formed so early in the star's life. Ideally, it would take billions of years, possibly longer, for the star to have a strong enough gravitational pull to kickstart the formation of such a massive planet. And even then, it would take such a huge planet billions of years to form to its current size and mass. But in just 2 million years, not only has the planet begun to form, but it has successfully grown to over 9 times the size of Jupiter. Scientists and astronomers believe this to be the first recorded incident of planetary formation through a fairly unproven method called disk instability. Disk instability occurs when a region of the circumstellar disk around a forming star becomes cold and dense, resulting in regional gravitational collapse. This collapsed region then begins to trap anything from lumps of gas to dust, causing a gaseous protoplanet to form. This has largely been a theory for decades and has never been observed in real time. This is because while scientists are fairly certain of how planets migrate, they never thought planetary cores could form this far away from their host star. AB Aurigae and Jupiter. Jupiter's formation process was much different compared to how AB Aurigae b is currently forming, such that Jupiter began to form much closer to the Sun and still migrated inwards to collect gases that make up its gaseous surface. This difference between Jupiter and AB Aurigae b is a result of how the initial core formation of these planets differ. While Jupiter started with a small rocky core, spinning inward until it gathered enough gas and dust to result in a fully formed planet, the core of AB Aurigae b is quite different. The exoplanet's core is most likely still made of mostly dust particles, although it is incredibly dense and compact, which has allowed it to pull matter to its colossal size without much limitation. If Jupiter were to form at a distance AB Aurigae b is from its host star, it would take tens of billions of years for it to fully form. And if AB Aurigae b were to form at Jupiter's distance from the Sun, we could have ended up with a binary star system, as it might end up being a star instead of an exoplanet. Furthermore, the massive exoplanet is still forming, with surface temperatures exceeding 2000 degrees Celsius. This temperature level is consistent with the accretion rate of such a huge planet, meaning matter such as gas and dust are constantly being pulled into it at high speed, causing collisions and friction that lead to its high temperature. The accretion rate of this exoplanet is equal to about 5,000 trillion tons of matter per day. That's roughly 66 billion tons of matter being pulled into this exoplanet per second. This is happening on a constant level and will continue to do so for the next billion years, until its host star completely clears the region of the circumstellar disk, such that there is no more matter to be pulled into the forming planet. So far, scientists have been able to identify over 5,000 exoplanets, none of which have ever come close in size to AB Aurigae b. Much of these exoplanets were discovered using what scientists call the transit method. This occurs when a planet orbiting its star causes a mini eclipse, such that it blocks a little bit of light from the host star. The amount of light and how light flows around the exoplanet enable scientists to determine the size, surface composition, and even its age. But so far, only about 60 of these exoplanets have been directly imaged using a telescope, and AB Aurigae b happens to be the youngest star ever imaged, as well as being the largest ever discovered. Following its discovery, scientists are now more confident that there's more than one way in which planets are formed. This broadens our understanding of the universe and could mean there are more exoplanets out there than previously expected. There may be hundreds of thousands, if not millions, of these massive gas giants currently being formed in stellar nurseries across the galaxy. Just when we think we know the secrets of how the universe works, it reminds us that we are still a primitive race with much to learn and understand about the cosmos.